Okay, we're going to do rational expressions, but this time we're going to be canceling the factors. Okay?
Okay.
And so we're going to talk about what the word rational, we're going to review what it means again. And so we'll come over here and do that. So we're going to just kind of rewrite that out here. And the word rational, if you remember, it has this word in front. It has the word ratio in it. And that ratio, do you remember what the word ratio means?
The fraction.
Very
right?
good. It means fraction. So this is a fractional expression, okay? So we'll have a numerator and a denominator, okay? And so let's look at some on the next slide here. And I have...
That's all of those.
That's not what I'm supposed to do. All right, so I have some fractions here. And what you're going to learn today when it said to canceling the factors, all we're going to do is reduce. All we're doing is reducing fractions, okay? But we're going to do it with extras. So it doesn't feel like you're reducing fractions, but it's the same thing. So when you had a 2 and a 6 and you were asked to reduce that fraction, what can you take out of both of them?
2.
A 2. And that's because 2 is on the top, and you have a 6 is the same as 2 times 3,
So
okay?
it'd be 1/3.
So we can reduce that out, right? And so what we did is we just broke this down into its factors. Just like we're going to be canceling factors. That's what our title is today. And so there is a invisible 1 at the top up there. So this was going to be 1/3. Okay?
Okay.
You've been doing this reducing and rational expressions for a while, but you've been doing it with exponents. Okay?
So doing like...
So we're going to have a 4 left on top,
So
right?
it'll just be 4y.
Yes, because our x's will cancel. This y squared is the same as having a y and a y, and so I'm breaking it out in its factors. That's what I'm doing, right? And I'm canceling them, so I'll just be left with a y here, okay?
Okay.
So all we're doing today is we're just going to be reducing fractions, even though it doesn't seem like it.
Oh, that's
okay?
all?
So the next slide, I already have this here for you. If we have this, this is factored. I have one factor here, and another factor here. Okay, I have a factor here and here. You with me so far? So if I have a factor that's in the numerator and the denominator, we can reduce it out or cancel it out.
Okay.
Do we have something in the numerator and the denominator that are the same?
The 3.
Yes, not just the 3, because it has to be in the
and the
parentheses.
x.
It has the x and the plus 3. That whole group has to come together. We can't just cancel a 3.
Oh, we have to cancel.
We have to cancel an x plus a 3, the whole parentheses.
So then that just makes x minus 5 and x plus 2.
Yes. Okay,
That's all?
so far. Okay.
Oh,
Now,
man.
this one right here was in a fractional, it should be in factored form. If we go back to here, when I had the 2, 6, I had to factor this 3 and the 2. Okay, so we're going to do that on this next one. We have something here. It's not factored. Okay? So we're going to rewrite the 2 and the x. And we're going to factor. You've been doing this with the box method for a while. This one up here.
Oh, so then doing...
See, this one's already down here. It's already factored for us. So we're going to put our box over here. Okay. And we're going to put... All right, so what goes in this column?
The 2 x's.
That's right.
And then negative 7 plus 3, I think.
This is a 2. Sorry, whatever it looks like. I don't know.
Oh! So then negative 2 and positive 1, I believe. Or maybe it's... No.
So that means we're going to put this in there. X minus 2, right in here.
And then x plus 2. 1.
Yes. Okay. So now, do we have any factors on the numerator that are the same as the denominator?
The
So
x plus 1.
The x plus 1, that's right. So I'm going to actually change colors. Okay, we also have another one. The factors in the numerator are 2 and x and the x minus 2. Okay?
Ah.
And then the denominator's factors are 3, x, and x plus 1. Do we have anything in common, numerator and denominator?
That we have a 2x and a 3x.
We have an x in both of them.
Uh-huh.
Okay, so we have an x there and an x there.
So we can take those out, right?
Yes.
So then that just leaves a 3 on the bottom.
Uh-huh.
And then would you do 2x and then minus 4?
You actually leave it factored. Leave it factored.
Okay.
You're used to unfactoring it.
Yeah.
You're used to doing the distributed property. Yes, so just leave it. And I should put that 3 in the center. Okay?
And so that's what you do?
That's it. That's it.
Oh,
Okay.
so you basically just take out all the things that are the same.
Yes, top and bottom. And we have to first factor it to find its factors to cancel. Okay?
Oh, okay.
And so sometimes they're already factored, and sometimes you have to factor them.
Okay.
Okay.
This
And
is
so-
better than the last one.
Right, and you learned a lot about all this factoring, and you've actually thought they were quite nice to factor.
Yeah.
And so there are going to be some factors at times. Remember that x squared minus 9 can be factored also. It doesn't have to be a trinomial. This can be factored into x minus 3 and x plus 3, if
3.
you remember.
Yeah.
And so don't forget you have those that are binomials that can be factored, and you have trinomials that can be factored.
Right.
And then they can, depending on how they are on numerator and denominator, we can
Uh-huh.
cancel quite a bit of them.
Yeah.
So all you're doing is reducing fractions. So a long time ago when you learned the 4 over 10, and you factored by taking a 2 out of both of them.
Yeah.
We're just doing the same thing. We're just doing with factors with trinomials and binomials. The reason we can take a 2 out of them is because that's 2 times 2. And this is 2 times 5.
So
and we have a
it's
2 in
2 and
common
5.
that we can take out.
Yeah,
Okay.
okay, that makes sense.
Okay.
This isn't as bad as the last one.
Yeah.
I didn't like the last one.